Okay, so most of us have played around with tools like ChatGPT, and let's be honest, it feels like magic. But the real AI revolution, the stuff that's truly changing the game, isn't just about the cool things these tools can do. It's happening a layer deeper, down in the fundamental architecture, the very blueprint of how we're building an AI brain. So let's get into it. I mean, just look at this timeline. It's kind of wild. It took decades to get from foundational ideas like LSTMs to the deep learning era we know. But now, we're seeing massive breakthroughs like GPT 4.0 and Gemini 2.0 pop up in just a matter of months. The time between these huge leaps is just collapsing. And here's the crucial thing to get. This incredible speed up isn't just because we're feeding AI more and more data or just making the old models bigger. No, we're seeing a fundamental shift to a completely new blueprint for how these systems are built from the ground up. So, to really get a handle on where all this is headed, we've got to look past the apps and pop the hood. We need to understand these new architectural blueprints. We're going to break down two of the biggest shifts that are making AI more powerful and, believe it or not, more efficient than ever. Okay, so the first idea is something called multimodality, and the second is this fascinating concept called mixture of experts. These two things working together are basically the engines driving this whole new wave, letting us build bigger, faster, and way, way smarter AI. First up, multimodality. The simplest way to think about this is that we're giving AI senses. Instead of just understanding text, a multimodal AI can see, hear, and read all at the same time, piecing it all together. It gets a much more complete, almost human-like picture of the world. And this slide just nails the difference. The old AI, it could read your question. That's it. But a new multimodal AI like Google's Gemini can literally watch a video, listen to you ask a question about what's happening in the video, and then speak the answer back to you. It makes talking to an AI feel so much more natural. All right, the second big shift is called mixture of experts, or MO for short. Now this is clever. Forget about having one single giant AI brain that's trying to be a genius at everything. The MO approach is more like having a team of specialists. You've got your math expert, your language expert, your coding expert, and so on. And here's why this is such a game changer: efficiency. A traditional dense model uses its entire massive brain for every single thing you ask it. It's super powerful, but also really slow and expensive. With an MOE model, there's a smart little router that looks at your question and sends it only to the one or two experts who can actually help. This is how these models can scale up to trillions of parameters without the cost just exploding. It's huge. So once you have these new, super efficient architectures, you can start doing new things. AI is beginning to move beyond just giving you a quick, instant answer. We're now seeing the first glimpse of models that seem to, deliberate. They appear to reason through a problem step by step. But this brings up the big question, doesn't it? We know AI is amazing at finding patterns, but can it really solve a tricky problem that needs planning, foresight, and a logical chain of thought? For a long time, that's been a massive roadblock for AI. Well, the latest models are starting to show that maybe they can. In the research papers, you'll see placeholder names for this ability, something like Q-star capabilities. But really what it represents is a huge shift from an AI that just reacts to one that can actually reflect. So how does this actually work? Well, when you give it a hard problem, instead of just blurting out an answer, it enters this thinking mode. It actually uses more computer power to brainstorm a bunch of different ways to solve the problem. It generates all these different step-by-step paths, and then it looks them over, evaluates them, and picks the best one. It's not just pattern matching anymore. It's a kind of simulated problem solving. And when you start to put all of these pieces together, the multimodality, the incredible efficiency, this new ability to think, it all starts pointing in one direction, toward the ultimate goal of the entire field: artificial general intelligence, AGI. So, AIGI isn't just an AI that's really good at one thing, like writing code. It's the grand vision, an AI that has the same kind of broad, flexible intelligence that we do, the ability to learn, to reason, and to adapt across pretty much any domain you can think of. So, what would that even look like? Well, we're talking about an AI that could learn on its own just by watching the world, that actually has common sense, and that can seamlessly blend what it learned from reading a book with what it saw in a video. And you can see now how those new architectures we talked about are the direct stepping stones to get there. But listen, this isn't all just about some far-off future. These powerful new AI models are already having a huge and immediate impact on how we create and share knowledge right now, especially in the world of science. This chart is just staggering. It shows the number of AI papers uploaded to arXiv, which is a place where scientists can post their work before it gets peer-reviewed. The growth is just exponential. AI isn't just a research topic anymore. It's a tool that's hitting the gas pedal on how fast research itself gets published. But there's a pretty serious risk here. As the source paper for our explainer points out, this flood of information means that a lot of unproven or even flawed research could spread like wildfire before it's been properly checked by other scientists. The traditional system that science uses for quality control is really struggling to keep up.
And this is where it affects every single one of us. This goes way beyond academic papers. It gets right to the heart of a much bigger question. In an age where information can be generated instantly by an AI, how do we as a society figure out what's real and what's not?
So let's just quickly recap the 3 core ideas from this explainer. 1, we're rebuilding AI with more senses. That's multimodality. 2, we're using specialized brains for massive efficiency. That's mixture of experts. And 3, AI is learning to think before it gives an answer. Which leaves us with one final, pretty important question. This technology is getting better at an exponential rate. But are our human systems, our ways of learning, of checking facts, of figuring out what's true, are they keeping pace? AI is learning faster than ever. The real question is, are we?